Now let's take a look at the solution of the problem where the ball is rolling toward a wall. So what we have is a ball rolling toward a wall at 2 meters per second, rebounding back at 2 meters per second. And we want to know the force exerted on the ball by the wall. Well, this looks like an impulse problem. So let's say this is what you did. Impulse equals F net times T equals mv minus mv0. Now, I know it's an impulse problem to start with because I have a collision, which usually identifies impulse, or what we'll learn later is momentum. But it's an impulse problem because I can only analyze one of the objects. It doesn't make sense to analyze the wall. It doesn't do anything. I only have information on one of the objects. So you were told it moves toward a wall at 2 and then rebounds back at 2 meters per second. Well, what I really want to do is find the force, so I'm going to use this portion of the equation to get the force. F net equals mv minus mv0 over t. Well, we could even factor things out. mv minus v0 over t. So you were told it moves toward the wall at 2 and back at 2. So are v and v0 the same? Are they both 2? Hopefully you said no. If you do think they are both 2, you're missing the vector nature of the problem. Now, a good reason to think that they're not both 2 even from the math. If they were both 2 meters per second, the net force would be 0, which makes no sense at all. We know there's a net force acting on the ball to change its direction. I didn't draw a picture on purpose to show you could get caught in a trap without one. You really, really need a picture. Toward a wall, let's say here's the wall, at 2 meters per second. Initially, it rebounds back, final, 2 meters per second. But since we have vector notation, we must have an axis. If we call toward the wall positive, that means in our equation, F net equals m, and that was 500 grams or 0.500 kilograms. If we call toward the wall positive, then the final velocity is negative 2. Minus 2 all over 4 milliseconds, 4.00 times 10 to the minus 3 seconds. And when you multiply this out, you get the net force equal to 500 newtons with a negative in front of it. You say, wait, how can I get negative forces? We're never allowed to get negative forces. In this case, we are. We are finding the net force. Usually when we are looking for an individual force, we resolve things into components, so the negatives are taken care of in the equation that we start with. Here, it is not. So this is the net force. But is that the force of the wall acting on the ball? For this problem, yes, because there are no other forces present. What does the negative mean? The negative simply means that the net force is directed away from the wall, which makes sense because the net force changes the motion of the object from 2 meters per second to negative 2 meters per second. So you need to be very, very, very careful. Make sure you label axes so you get the vector nature of the velocities.